Hey guys, the objective of this video is to find phi dash given c dash for an undrained case. We do that by going from the total stress to the effective stress on Mohrs circle, and then we use our failure criterion to find phi dash. So in our example, the axial stress is 150 kPa, the radial stress is given as 90 kPa, and the pore water pressure at failure equals 20 kPa. And once again, this is an undrained case. So we know for an undrained case, we can either do total stress analysis or effective stress analysis, and we know that effective is much easier. We always use effective. Most of the time we use effective. So if we were to draw this Mohrs circle, the axial stress, we said in the previous video, the axial stress is the same as sigma 1 and the radial stress is the same as sigma 3. And once again, these are total stresses. So we're going to plot these. So we would have sigma 3, which is equal to 90, and sigma 1, which is equal to 150 kPa. So if we were to draw a Mohrs circle, it would look like this. I don't need to draw the bottom, it's not so necessary. So now, we need though, for our failure criterion, this to be an effective stress, and we're given effective stress parameters. So we need to go from total to effective stress. So we know how to do that. We know that sigma 3 dash will equal sigma 3 minus the pore water pressure. So sigma 3 is 90. The pore water pressure at failure, it has to be at failure, is 20. So minus 20 equals 70 kPa. Similarly, sigma 1 dash will equal sigma 1 minus u. So sigma 1 is 150 minus 20, which will equal 130. So now we can draw our effective stress Mohrs circle. So sigma 3 dash is 70, so that's going to be around there. This is 70. And sigma 1 dash is 130, so it'll be around there. And we can connect our circle, and now we have in blue our effective stress Mohrs circle. So all we did graphically was we subtracted the pore water pressure 20, so we went from here to here by minusing u, which we minus 20, and we went from sigma 1 to sigma 1 dash by minusing 20. So that was going from our total stress Mohrs circle to our effective stress Mohrs circle. Now, this is just a visual representation of what's going on. We now need to find the phi dash. So we need to find phi dash. And we know that our failure criterion is sigma 1 dash equals n phi sigma 3 dash plus 2c dash square root n phi, where n phi is equal to 1 plus sine phi dash on 1 minus sine phi dash. So the first thing we know is that we're given c dash equals 0. So straight away, this is 0, so that eliminates that part of the equation. So we're just left with sigma 1 dash equals n phi sigma 3 dash. So we know that sigma 1 dash is 130 equals, now we have n phi outside of sigma 3 dash, which we found to be 70. So we can rearrange this to get n phi equals 130 on 70. And we know that n phi equals 1 plus sine phi dash on 1 minus sine phi dash, which means 1 plus sine phi dash on 1 minus sine phi dash is equal to 130 on 70 is about 1.86. So we can rearrange this to get 1 plus sine phi dash equals 1.86 outside of 1 minus sine phi dash. And this equals 1.86 minus 1.86 sine phi dash. We could then rearrange this again to get 2.86 sine phi dash equals 0.86, which means that sine phi dash equals 0.86 on 2.86, which means that phi dash will equal the inverse sine of 0.86 on 2.86, and we get a phi dash of around 17.5 degrees. Okay, so that's how we do the question. We need to first convert our Mohrs circle from total to effective stress. I mean, for this example, it isn't even that necessary to draw Mohrs circle, but I've drawn it just to show you what's going on. So we convert our total principal stresses to effective stresses, and then we use our failure criterion to set up an equation in order to find phi dash, which is the angle, the friction angle. Anyway guys, hope that helps. I'm going to do a couple more examples, so I would recommend checking them out.